Hello and welcome guys. In this video I wanted to show you how I'm doing profiling in Node.js for memory and for CPU usage. Why might you need this information in case if you are running application somewhere in containers, right? Assuming in Kubernetes and you see that your pods are failing because of JavaScript is out of memory, or you don't know why your backend is crashing. This might be the place to look, where to start. So I would say that this is not going to be a tutorial regarding Grafana and Prometheus. I'm using them here. So I will show you how I made these beautiful dashboards and what's shown on them. But overall, yeah, I'm just going to briefly explain what it is. But once again, this is not a Grafana and Prometheus tutorial. Just a brief pause. If you enjoy this type of content or want to watch me live code projects like this, hit subscribe button and ring that bell. It is free, takes 2 seconds, and helps me a ton. As you can see, only a very small percentage of you guys actually subscribe to my channel. Anyways, thank you very much for all the support. Let's continue. So let me go through README first, so you can have a better understanding of what I'm doing. So this is a dummy project. I'm running it in a Docker and Docker Compose, but in my project where I'm working, I'm going to be using this in Kubernetes, so it's same, I would say. So you can just start it up with Docker Compose up. I will go through the code as well. Here are credentials, how you can allocate memory to different endpoints. I'll show these endpoints as well, and monitoring dashboards. Once again, I will walk through it right now. And important parts here, I set memory limit to 256 for this test because so it's easier to see what's happening. And yeah, these are parameters where you can adjust them, right? So you can test different memory sizes, different memory limits, sorry. All right, so, and here I wrote down what memory, because I'm going to be showing on the graphs different memory types, so which one of them means what. And I also mentioned this in controller, where we are allocating for different memory types. All right, and here just some basic information, and this is pretty much it. And the last thing is, before adding this, do your own research, right? I tested that there is an interceptor which logs every request. You can change this ratio, obviously, but it was adding like 1 millisecond, so very little overhead. But before adding to your application, just do your own research. All right, so first thing is what is Prometheus and Grafana and why I'm using them. So here on the screen, you can see Grafana. This is Grafana dashboards. They are pretty much showing information which is collected by Prometheus. So Prometheus is, you can call it a backend, which collects the metrics. It collects some default metrics once you connect them to your Node.js application, and you can send custom metrics as well, which I'm doing here, but not all of them. And Grafana is essentially a UI, which you can customize and edit as you like. So I sent some requests already, and let's just go quickly through what I'm showing here. So I have 2 dashboards, one for just overall memory leak detection, not specific to, okay, this dashboard is for the endpoints, but it's more of a general one. And this dashboard is going to be specifically how much each endpoint uses. All right, so let's go through the first one. So here we see the memory growth rate. We have the RSS memory, which is the memory of the process, and heap growth rate. I just sent some requests to add some load so we can see how it's moving. And it's just like 5-minute slice, and every 5 seconds we're getting a refresh. Then here is memory leaking endpoints, potentially, right? We need to do more investigation to understand that these endpoints indeed are having the leak. We can do it through the profiling. I'll show it to you once again later. So here we have garbage collection frequency, event loop lag. They go hand in hand together. So the more garbage collection we have, the more memory pressure, the more garbage collections we are having. They are blocking event loop, and we're having event loop lag. So the higher are both, the worse it is, right, for your application. And in the README, I added some like boarding size basically, right? So you can understand approximately what is happening with your application at this state. All right, let's go through the second dashboard. So here we have, once again, just overall memory usage. I added here as well in case I will use just one dashboard, or I will combine them somehow. So here we have container memory. As you can see, we are I don't know, we are above the limit, but I think it's just some error. We can't go above the limit. And yeah, then we have HTTP request rate. So the problem we were having is we didn't know how many requests our backend was receiving and which specific endpoints were causing the problem. So this dashboard solved this problem. So we're having, as you can see here, is written every specific endpoint, how many we are receiving, and here we're seeing the memory consumption by each endpoint. And here we see average request duration. So here we see, yeah, just the data is pretty much flat because there are two endpoints which are being updated all the time. I mean, I'm triggering all the time is health and metrics, and pretty much they are overflowing the chart right now because there are way too many of them compared to the other ones. But in production application, right, you will be receiving way more of other types of requests. So it's not going to be like this flat. And here we have overall just what is happening with your memory, what kind of memory your application is using right now. So we have external, new, old, and code. So once again, in the README, I left notes what is what. So external is essentially what is in your native modules, meaning in C++. So the new memory space is recently created objects. This is, as written here, temporary data. And this is minor GC loop. Basically, it runs more frequently and it's light. And old space, this is major GC. So this is for long-lived objects which were either not cleaned up or survived the minor GC. So now let's look at the code and how am I doing this. All right, so the first thing I wanted to show you is actually Docker Compose setup. So it's fairly simple. So we have our I'm using Nest application here. The important things is I'm limiting the heap size here and I'm limiting memory in here. The next thing is volumes, not that important. So in terms of Prometheus and Grafana, you just need to be aware of the volumes, where the configurations, because yeah, configs are in volumes. So here's the Prometheus volumes and here is the Grafana's volumes. Why this is important? Pretty much they're here. And as you can see, here's Grafana and Prometheus folders. In Prometheus, probably you don't need to change anything. And in Grafana, we have dashboards here, the one I showed you before. So here we have the panels. And pretty much this is the information in case if you would like to customize, change some metrics, etc. So you can do it here. If something is unclear here or you haven't worked with this before, you can just drop it in your favorite AI, and they are very good with this kind of boilerplate stuff. So they will be able to edit it for you. All right, what else is interesting here? So I have this profiling module. And pretty much all the endpoints are here. Just FYI, I didn't aim here to write some kind of clean code, right? This is just for testing, so the code is kind of not ideal, let's say. So the first one is we have a memory stress test controller. So here we have all the endpoints you can use to stress test your application. So we have allocate memory. It allocates external memory, right? Because we are creating buffer here and it will create external memory. So this is what I triggered before. And that's why we have this big red line, right? Big, I mean, red space. This is external memory. The other ones are create memory leak. So this one creates the old memory, long-lived, because we are here, what we're doing, we're creating the circular dependency. So we are pushing an object into array and then referencing this array in the object. So creating circular dependency, and garbage collector is unable to clean it, right? Because it's circular dependency. And then pretty much we have as well different types of old memory creation. First, they will go into new space, but over time, the garbage collector won't be able to collect them and they will move into old space. Yeah, recursive function is the same, just different types, right? It's doing it as well. So here we are pushing into array, and here we are simulating the third one, simulate real usage. It creates all three. So we are allocating into buffer, we are creating arrays, and once again, we are creating arrays. So we will have new memory, we will have external, and then we will have old memory. And the last one is we have CPU intensive task. Here I created like breakdown between light, medium, and heavy, but pretty much they're all going to do the same thing. The light CPU work. So what it does, it creates a function which will run for some period of time. And then, yeah, we will be able to see these functions in profiling. So you can test it out, how it's going to look like. And the rest is pretty much just helper functions. I didn't create any services. Once again, the aim was not clean code or anything like this. So as well, we have interceptor. So this is the thing I mentioned before. You should test on your own just to make sure that it's not creating too much overhead. So here well, you can create some kind of filter here, right? Like to activate it on like 10% of requests or whatever in production. Probably you don't need to do it for every single one. But for right here, I didn't add any filters or anything like this. So what we are doing here, we are getting the starting memory and we are taking the end memory. And then we are creating delta. And delta is being sent to Prometheus, right? And then we are showing it. So this is pretty much it. Nothing special, right? We are emitting metrics, and this is like Prometheus metric servers, and it's recording requests and recording the endpoint. The only problem, this might not be ideal to track specifically how much each endpoint is tracking, because you might have something in the background running, meaning like you can have set timeout, right? And your function, like function 1 ended and returned the response, and then the another function is coming in, but because the set timeout callback is running at the moment, you will have, like in the function B, higher memory usage, right? But it's not specifically function B, so it's not ideal. But overall, it will give you at least brief like understanding what was happening before. I don't know. I didn't come up with any better idea, but in any case, to solve this problem, we will need to use our third controller, or to add anywhere you would like endpoints to create heap snapshot, and then look at the heap snapshot and specifically to understand which endpoints, which objects, arrays, whatever were created in JavaScript at this time, or which functions were called. And we have as well CPU profile here. So yeah, let me go. I think this is pretty much it from the code. Nothing else here. If you will have any questions, feel free to ask, but yeah, pretty much nothing special here. So the only thing I will mention that this saves everything into folders here. We have heap snapshots and CPU profiles. I just took a heap snapshot just now just to make sure that everything is working. So everything is okay. And yeah, the same for CPU profiles. I'm saving them right now into folder just for simplicity's sake, but you can store them in some kind of S3 bucket once it's a actual application, right? Okay, let's take a look at the profiles. So as I said, I have already memory profile here saved, and I triggered some endpoints. And what we are looking for is retained size, right? This is what is garbage collector is unable to clean up. And here we can open them up and investigate. So here, for me, it's quite easy. We have like memory stress test storage, right? You can find basically what is consuming all the memory, and we can see here, right? It's specifically this map, right? We can see it's a map. And now let's check if we have it in the code. And indeed we do, right? And you can find something in your code like this, and then go investigate what is happening with it. Obviously, in this memory stress storage, we are pushing tons of data, and that's why it's just saving everything, right? And you can see here how many objects is there, and that's why it's retaining so much size. All right, the same you can do for CPU profiling. Let me just show how we can do it. So what we will need to do, we will need to start CPU profile. Am I not running? Oh, actually my application died. Okay, let me just restart it and start it back up so we clean our memory. Let me check the metrics. What is happening here? Are we good? Are we running? We are running. Okay, yeah, new metrics. So the memory cleaned up. The application is running again. So if you remember previously, we had this gouge filled up. right? It was full, so application actually crashed, right? So now let's send just some, well, let's actually start profile. Then we will send CPU intensive task, right? It's going to run for about 5 seconds. And now let's end the CPU profile, and it's saved into file. And now let's open it and look what we have. Node.js, CPU profile. All right. Now we have our callbacks which were triggered, right? And here you can see like medium CPU work. This is what was called in our code, right? So medium CPU, it's here. So we have medium by default. That's why I didn't send any query params, and yeah, the medium got triggered. Just FYI. So we have mediums, they're triggered with random duration. As you can see here, they're visible basically in the profile. And this is what I wanted to show you. You can view here, right? We have garbage collections here. We have CPU intensive tasks. So pretty much you can do your own investigation here and understand what was happening with your application in case CPU was the problem. You can see all the calls. And also now let's go through our endpoints for memory and let's see what's going to happen. Let's trigger some of them. Let's trigger recursive function. Let's create a memory leak. And let's allocate memory. As you can see here, allocate memory is external memory. It's just perfect, like 52. If we send 50 more, we get 102, right? Amazing. And let's simulate real usage. And let's take a look at our charts. As you can see, like external memory climbing up rapidly. So as you can see, process is consuming way more memory. Heap is increasing as well, but not as much as I would think. So request rate is pretty much the same because I sent just a few requests, right? Nothing special for in terms of these metrics. And here we can see that profiling metrics are climbing up, but this is because these ones were added in here, and because of that, this metric increased. Also, what I wanted to show you that you can inspect this ones, not this one. You can view them. View will open them on a full screen, and you can explore. Yeah, this is what I wanted to show you. And here you can change like bars, points, stacked lines, right? You can customize them. And once again, in the code, in where I showed you where the config, you can adjust these things as well, and they will look like this. Well, basically, they're adjustable. All right, let's go back. And here we have memory usage by endpoint. This is very nice. You can see like endpoints, some endpoints started to add the memory. Let's look at the full screen, right? You can see like some of them weren't here before, and now, well, this is a previous test. Then the memory dropped. Then the new one was, right? This one was not here. We added CPU profile, the new callbacks. Basically, you can investigate and see what's happening, and they started to climb once I send the requests. All right, and as you can see, external memory just exploded because I sent way too many requests for external memory, and the old space once again climbing as well because garbage collector, I mean, is unable to collect all the memory, to clean up the memory, sorry. Yeah, it's growing up because there is a recursive function and it's getting triggered over and over and over again. All right, so this is pretty much it from the video, from everything I wanted to show you. I hope it was helpful. Thank you for watching. Take care. Bye-bye.